Okay, here's an explanation for 310F. Sorry. Okay, they want you to figure out the reactions. So I drew a little diagram here of that situation. I've got the beam shown down here in white. I've got reaction 1, which is 4 feet right there from that end. I've got reaction 2, which is 4 feet from that end. I've got my distributed load here, which is a total of 2,000 pounds. I've got my distributed load here that is a total of 6,000 pounds. We've also got some existing point loads. We have 1,000 pounds down here at the end, and we have 3,000 pounds right here. These are the orangish color is the dimensions they gave you in the book. And then what I do is I turn the evenly distributed load into a point load. To do that, you need to figure out what it is. In this case, it's a total of 2,000 pounds. So it's going to be a point load of 2,000 pounds in the middle of that load. And according to the book, that's 6 feet long, 4 plus 2, so it'll be 3 feet from the end. So I didn't write that up there. So that's a new point load of 2,000 pounds. So then I did the same thing over here. I colored it purple so you could see it clearly. We have this evenly distributed load of 6,000 pounds. That load is 10 feet long, so the middle of that load would be at 5 feet from the end, or either end. So it's a point load now of 6,000 pounds, 5 feet from either end. Now you have to do the math. So you're going to have, let's see here, you're going to have the sum. Let me turn that to black. You're going to have the sum of the moments, can't write too good on here, about R1, reaction 1. All of those is going to equal, hold on, so you have the sum of the moments about R1 is going to equal the sum of the moments about R2. That's so this can be in equilibrium. So we just have to figure out one of those. So I'm going to write that out. Let's see here. This will work. So R2 or R1 is they're 8 feet from each other. So you're going to have 8 R2. So I'm going to do the sum of the moments about R2 equals the sum of the moments about R1. So those are going to be, about R1, we have this 1,000 pound load going in this direction, and that is, that will be a negative moment. So you're going to have equals minus, and that is 4 feet long, 4 feet times 1,000 pounds. Then you're going to have the next load is going to be this one, which is 2,000 pounds now. It's a 2,000 pound point load. And so this distance right here between R1 and that is going to be 1 foot. And that's still going to be negative. So it's going to be minus 2,000, I'll do it the other way, minus 1 foot times 2,000 pounds. Then we're going to look over here on this side of R1. We have a 3,000 pound load going clockwise, so that's going to be positive. So then we're going to write plus 3,000, or 2 feet, it's 2 feet away, plus 2 feet times 3,000 pounds. And then our next load is also going to be going positive because it's going in the clockwise direction, plus, and that's going to be from R1 is going to be 2 feet, and 5 feet is 7 feet. So that will be 7 feet times 6,000 pounds. And then, so you do the math. You're going to add all this up. And let me just, so I don't waste time, let me pause this again. Okay, so you can see that I've done the little math here. So I've got minus, well, I have one too many zeros there, but forgive me, I can't erase that now. We got minus 4,000 foot-pounds, minus 2,000 foot-pounds, plus 6,000 foot-pounds, plus 42,000 foot-pounds. So now if you add all that up, I'll get my calculator. There it is. Okay, so we got minus 4,000, minus 2,000, plus 6,000, plus 42,000 equals 84,000. Let me make sure I don't think that's right. Okay. Minus 4,000 minus 2,000 plus 6,000 plus 42,000 equals 42,000 pounds. That's right. So, I guess I got to draw a new text box. So 8R2 is going to equal 42,000 foot-pounds. Now, if you do the algebra, you know that you can say that R2, make that capital, R2 equals 42,000 divided by 8. So therefore, R2 is going to equal, that's a reaction 2, is going to equal 42, 1, 2, 3, divided by 8 equals 5250 foot-pounds. Now you just have to figure out what R1 is. And you know, for this to be in equilibrium, that R2 plus R1 has to equal all of these. So R1 is going to equal 1,000 plus 2,000 plus 3,000 plus 6,000, and then you're going to take out minus R2, which is 5250. And R2 is not in foot-pounds, that's just in pounds. That was my mistake. So you do that math, and you get R1 equals, calculator, you got 1,000 plus 2,000 plus 3,000 plus 6,000 minus 5250 equals 6750. So we'll write 6750. And I guess we're checking the back of the book, make sure that I'm correct. And I am. So I hope that helps you. What the heck happened? Okay. And let me know if you have any other questions.